Real-world DevOps engineer. Real-time scenario-based DevOps engineer interview questions and answers. Scenario 1. Deployment fails during release. Question. During a production release, the deployment fails halfway. Some services are updated, while others are still running the old version. How would you handle this situation? Answer. 1. Rollback plan. A. If you have a blue-green deployment or canary release strategy, initiate an automated rollback to the previous stable version. B. If there is no automated rollback, manually revert the updated services. 2. Troubleshooting. A. Check deployment logs and identify the root cause of failure, example missing dependencies, version mismatches. B. Validate the service dependencies and resolve inconsistencies. 3. Post-mortem analysis. A. Identify why the deployment failed, example faulty CI/CD pipeline, incorrect config. B. Improve the deployment process by adding better validation steps. Note: always have a rollback strategy and use feature flags to reduce risk. During production releases. Scenario 2. CI/CD pipeline is slow. Question. Your CI/CD pipeline is taking 45+ minutes to build and deploy. How would you optimize it? Answer. 1. Parallel execution. A. Run unit tests, integration tests, and builds in parallel to reduce pipeline execution time. 2. Caching. A. Cache dependencies, example, Docker layers, Maven packages, NPM modules, to avoid repeated downloads. 3. Selective tests. A. Implement test filtering to run only impacted tests instead of the full suite on every build. 4. Resource scaling. Use auto-scaling runners or distributed builds to reduce build time. Note: use tools like Jenkins with parallel stages, GitHub Actions matrix builds, or GitLab caching to speed up pipelines. Scenario 3. High CPU or memory utilization in Kubernetes. Question. Your Kubernetes pods are frequently restarting due to out-of-memory, OOM, errors. How would you troubleshoot and fix this? Answer. 1. Monitor resource usage. A. Use kubectl top pods or kubectl describe pod to check resource usage. B. Identify the containers consuming excessive CPU or memory. 2. Resource limits and requests. A. Set appropriate resources.limits and resources.requests in the pod spec to avoid OOM kills. 3. Horizontal pod autoscaling, HPA. A. Add HPA to scale pods based on CPU or memory thresholds. Note: use tools like Prometheus plus Grafana for better resource monitoring and visualization. Scenario 4. Jenkins job failing intermittently. Question. Your Jenkins pipeline occasionally fails, but when you rerun it, it succeeds. How would you diagnose and fix it? Answer. 1. Check console output. A. Review Jenkins logs inside the /var/log/jenkins/jenkins.log to identify transient issues. 2. Isolate the issue. A. Identify whether it's a flaky test, network issue, or race condition. B. Run the job with retry logic or wrap it with a wrapper script to retry on failure. 3. Improve stability. A. Add retry logic in Jenkins pipelines using retry blocks. Note: use Jenkins pipeline libraries and monitoring tools to identify flaky builds. Scenario 5. Application fails after Docker image update. Question. After updating your Docker image, the application fails with a 404 error. What steps would you take to debug this? Answer. 1. Check Dockerfile and image. A. Verify if the new image exposes the correct port. B. Check the entry point and CMD for issues. 2. Container logs. A. Run Docker logs to check for errors. 3. Port binding. A. Ensure the port binding is correct in the Docker run command. 4. Health checks. A. Verify if the health check endpoint is correctly configured in the container orchestration tool, example, Kubernetes, Docker Swarm. Note: implement proper health checks and version tagging to avoid breaking changes. Scenario 6. Pipeline security issues. Question. How would you implement security in a CI/CD pipeline to prevent vulnerabilities? Answer. 1. Code scanning. A. Use tools like SNYK, SonarCube, or Trivy to scan for vulnerabilities. 2. Secrets management. A. Store sensitive data in Vault, AWS Secrets Manager, or Kubernetes secrets, not in the codebase. 3. Static code analysis. A. Integrate SAST tools, example checkmarks, Fortify, into the pipeline. 4. Approval gates. A. Add approval stages for sensitive deployments. Note: automate security scans in the pipeline to detect issues early. Scenario 7. Git merge conflict during CI/CD. Question: what would you do if you encounter frequent Git merge conflicts in your DevOps workflow? Answer. 1. Branching strategy. A. Use Git flow or feature branches to avoid direct commits to the main branch. 2. Automated conflict detection. A. Add pre-merge hooks or GitHub actions to detect conflicts early. 3. Rebase and merge. A. Use Git rebase to keep your branch in sync with the main branch. Note: regularly rebase feature branches to avoid large conflicts. Scenario 8. Infrastructure as code, IAC, drift. Question: how would you detect and prevent drift in your Terraform infrastructure? Answer. 1. Drift detection. A. Use Terraform plan to identify drift. B. Automate drift detection with GitOps workflows. 2. State locking. A. Enable state locking using S3 plus DynamoDB to prevent concurrent modifications. 3. Auto remediation. A. Use pipelines to automatically apply changes and resolve drift. Note: use Terraform Cloud or Atlantis for automated drift management. Scenario 9. Slow application startup in Docker. Question: your Dockerized app takes a long time to start. How would you troubleshoot it? Answer. 1. Optimize Dockerfile. A. Use multi-stage builds to reduce image size. B. Use copy chown instead of run chown to optimize layer creation. 2. Lazy initialization. A. Load large configurations asynchronously after startup. 3. Image layers. Minimize Docker image layers by grouping commands. Note: use Docker builds caching to speed up build times. Stay connected for more videos. Please like, share and subscribe.